Okay.
Uh, Hello, everybody, and thank you for joining us on another webinar at Microsoft. My name is Nick Zulfikar. I am the Director of Client Services here. With me is my colleague, Ron Hussain, who's our Senior Technology Evangelist. Today, we're going to be talking about PubSub and continuous query messaging patterns in .NET. We'll discuss in detail some of the use cases, such as app coordination and data sharing. Typical .NET messaging platforms such as databases and messaging queues are not very scalable, and they can slow down your message delivery. This could have a huge impact on the applications that might be waiting on those messages. We'll show you how NCache or any other distributed caching solution in comparison is so much faster, scalable, and reliable. Ron is going to take us through the presentation today, talk about some use cases, and basically go over the presentation. So with that, I'll turn it over to Ron. If there are any questions, kindly type them in the questions box on the right-hand side, and I'll be able to ask those for you. Ron, kindly take over, please.
Very good. Thanks, Nick. Hi, everybody. My name is Ron. I'll be your presenter for today's webinar. And as Nick suggested, the topic that we've chosen today is going to be fast PubSub messaging and CQ. CQ stands for continuous query in .NET applications. So this is going to cover some advanced messaging features, that you can utilize within NCache. But it is going to be a general webinar. I'll talk about PubSub and CQ as a general technology, what these technologies are for, what are the use cases, how you can utilize and why you should plan on using them, and then we'll talk about some of the scalability and performance related bottlenecks that you have with these features, and I'll present a distributed cache as a solution for that. And we have a pretty detailed list of features, some hands-on examples, some use cases that I will cover in this particular webinar. So let's keep it as an interactive webinar where you can always join in, post as many questions as you need to, and I'll be very happy to answer all those questions for you. So assuming everything looks good, I've already got confirmation that you can see. All right. All right, so I'm just confirm if you can see our screen and everything looks good, and I'll then get started with the presentation. I just got a message in the chat window that there are some background issues, so please confirm on that. Everything looks good, guys?
Yeah, Ron, I think.
All right, just got the confirmation. Thank you. All right, so let's get started with the presentation. It's fast PubSub messaging and CQ in .NET apps. Let's first of all get started with what exactly is PubSub. PubSub is a publisher subscriber async messaging paradigm. It allows you to send messages between different components, different applications. We'll talk about what sort of common use cases that you have with the help of PubSub and why you should consider using it. Just to let you know that the messaging paradigm of PubSub, it's a very loosely coupled, so in some cases it's decoupled or in some cases it's loosely coupled. And it has three main components, and then within those main components we'll talk about specifics, what exactly each component does. So we have a publisher, we have a subscriber, and then we have a communication bus, a broker. Publishers are supposed to send messages to the communication channel, which actually keeps them for a certain period of time dependent upon the properties of that messaging channel, and then it would actually relay it to the subscribers, and subscribers on the other end are the ones who have subscribed to a channel, and then they are interested to get the notifications. And within publishers, you don't have to know about what the subscribers are and vice versa, and subscribers only are connected to the communication channel, and similarly publishers are also only connected to the communication channel. And even if they're not connected, for example, there is no publisher and messages can still be relayed to the subscribers, the current messages, and if there's no subscribers, the publishers can still send messages to the communication channel. So it's a very loosely coupled, and that's second point as well. It's a very loosely coupled architecture, and that's the beauty of it on the publisher and subscriber end. So, in terms of space, in terms of time, in terms of synchronization, there's a complete decoupling between your publishers and subscribers. They can, coexist, and then they can exist independently as well. And they are not dependent on one another at all, right? So they don't have to be at the same space. Publisher can send messages at a certain time. They don't need to have any synchronization, or they don't have to develop any point to site or point to point communication in order to achieve this messaging. The goal here is to make overall system more reliable, more robust, more stable, and more scalable, so that it keeps working without having any dependencies on one another. Then there is a separation of concerns, as you see about this whole architecture. Within the communication channel, since messages are kept for a short period of time and then they are relayed as soon as there is a subscriber message is going to be transmitted, you can also create topics within the communication channel, and publishers can publish to a certain topic. That's a message of certain type which goes to a topic. So you could have all the customer messages or order messages in their own respective customer and order topics as well. And then subscribers have ability to actually connect to the right topic and then subscribe and get the notifications of a certain interest. So it serves a simple purpose, a very simple, unique use case in most of the cases. You can separate out messages based on the load, based on the type, and messages the payload, which gets transferred between your subscribers and publishers. So this is some of the characteristics, some of the major ones that you would see with PubSub. Next thing we'll talk about, actually let's have a look at the diagram as well. So this is an architectural breakdown. So you have a topic. This is your communication channel right here. There is a publisher application, a component. It could be a serverless application, it could be a server application. It's entirely up to you. Then there are subscribers, which are actually on the receiving end. They are connected to this communication channel. Publishers also connect to the communication channel. Publishers publish message to the topic, and then they continue on their own functionality. They don't have to wait for the acknowledgement. Similarly, publishers can add messages to another topic as well, and then subscribers who are connected to a certain topic, subscribe to a certain topic, get notified via events or via callbacks through all the messages that they need to receive. So communication channel is the main binding factor. That's why I call it loosely coupled. It's not 100% decoupled, but on the publisher and communication side, it's loosely coupled. Publisher and subscribers can be completely decoupled, and it would work independently in comparison to one another. So you could have publishers going down, subscriber going down. You can perform upgrades, maintenance. The overall, the essence of this PubSub model, it would remain working from a publisher to the communication channel, and from communication channel to the subscriber end without any issues. So let's talk about why you should consider using PubSub. Now that we've defined that it has these components right here, it is decoupled, loosely coupled and decoupled, and you have a topic where you can have a separate type of message, or based on the load of messages, you could separate out messages into those topics. But why? What are the main benefits that you get in terms of using PubSub? Why you should consider using PubSub, and what sort of applications would consider using PubSub? First of all, the most important benefit of it that I see it, we see that there are a lot of microservices oriented applications being developed, right? So there could be some workloads, that you can use with the help of serverless apps. So this is a common trend that you're seeing, that there are a lot of server applications, API based. They're doing certain tasks, and they don't need any sort of a server or any centralized mechanism to manage, or let's say they don't have to synchronize in terms of a centralized management point of view. So what if these microservices or serverless apps needs to interact with one another? They need some data that they need to consume in a combined manner. Typically you would go with the database, right? So database, one has to publish data to the database, another has to poll, look for that new data being published. So it would be slower, and then it would be an implementation of connecting to the database, and then be able to ensure that the right information is passed on to the right consumer, and these are all serverless apps, so there is no central server to actually manage that. You have to have a centralized data storage in order to achieve this. So that is one important aspect of PubSub, that you can introduce a PubSub where these serverless apps can act as publishers and subscribers, and you can have an intermediary layer where publisher can send messages to the the communication channel, which could be a message bus, this could be a distributed cache, this could also be a database, and then it can return, and then subscribers can be notified via push mechanism instead of pull, right? So they can continue their own functionality, and while there is a message that needs to be delivered, while there is a data that needs to be shared, publishers would publish that, and then subscribers would get notified and receive that that data as it gets made available. So you don't need to implement direct communication between microservices, serverless apps. So that makes it very simple. It's very flexible on the communication end as well. I'll use that as a separate point as well. So it allows you to build an interaction between serverless apps by using the PubSub as a backbone for it. So that's our first kind of benefit that you get. Then in any sort of application, it could be a web application managing some backend web services, and those web services could have some workflows. They need to interact, they need to share data, they need to perform some computations, or they need to stream data and use that data, or be able to perform some monitoring information around it. Typically you would actually poll for information, right? So PubSub, the nice thing about PubSub mechanism is that the communication channel has a track of all the subscribers for a given topic, and then it pushes information onto the subscribers instead of poll. So this actually reduces your delivery time. So it's a push instead of a pull model. Pull, I'll give you an example of SignalR. SignalR applications do a lot of similar things, where ASP.NET web application, typically it's a real-time application. It would actually have to, typically it would have to fetch data while data is already published on the server end, right? So there's no way until you request and get the new updated data, and there could be a polling mechanism around it, which is slow, and it's against the very nature of real-time application, where you need data to be made available instantaneously. On the other hand, if you plug in SignalR, and by the way, we as an NCache provider use PubSub behind the scenes for SignalR backplane. So in that case, actually SignalR takes care of that. It actually takes control of your communication architecture. It sends all the messages, all the new information by invoking a JavaScript function on the client end, and it would actually push that information as soon as it's made available. So it's a push against a pull, and push is always faster. It reduces your delivery time, and PubSub is exactly based on that, where subscribers get subscribed and then they do their own thing, right? They can continue functionality, and they don't have to poll for any messages or changes after certain intervals. It's the communication channel which has to have that intelligence, where it actually sends those events to the subscribers, and they actually receive those events or messages as that message needs to be published. So push instead of pull mechanism is a lot faster. It improves your throughput. You can deal with a lot of messages in a faster manner, and that too under peak load as well. Then third important benefit of PubSub is it simplifies your communication architecture. No point-to-point connections are needed. This is something that we discussed as part of our serverless apps as well. So it would be very difficult if you have your microservices, and then those microservices need to have interaction with one another. You need to keep track of those microservices. You need to have information about what data is being published by what server instance, and what are the consumers of it. So it would be multicasting or broadcasting. So it would be a lot of painful implementation that needs to be done as part of this communication channel. PubSub takes care of this. You can actually reduce your communication code complexity. You don't need to track your peers. You can do dynamic targeting, so you can just publish it to the channel, and then you simply broadcast it to all the subscribers who have actually subscribed to the channel. So that's the beauty of it, that you don't have to manage the communication complexity yourself. It's part of the PubSub mechanism. And with NCache, I'll give you NCache as an example going forward. We have this built into it, where you can have a list of subscribers, and those are going to be notified regardless of how many data or what sort of data is being published. Then you develop and manage independently. For me, that's the most important benefit. These components are loosely coupled, right? So you can develop subscribers, publishers, their logic on how they deal with messages. For example, let's take an example of orders, right? So you're processing orders a certain way in a month where you have a lot of sales happening, right? And you can simply chain that implementation in the next month altogether, right? And since you're just dealing with a communication channel, so publisher can be implemented, managed independently in comparison to your subscribers. They have no interdependency on one another. So components, publishers and subscribers, and even communication channel, this can be developed, upgraded, changed independently from one another. Mostly it's true for publishers and subscribers. It's very flexible on the behavioral side of things, where you can change behavior, you can make maintenance, you can upgrade, and it does not have any dependency. While publisher is publishing data, it just needs the communication channel. It doesn't have any dependency on the subscriber. And then while you have some messages in the communication channel, subscribers would get those messages, and publishers can actually be stopped, or they can, they can be disconnected from the communication altogether. So since it's a loosely coupled scenario, you can develop and manage your communication through PubSub in a very flexible manner. So that's another benefit. So these are some of the benefits. There are many more. This would make an easy decision. If you need a requirement where you need to have a loosely coupled communication between your components, whether it's serverless components or server-based components, server apps, web services, ASP.NET web applications, doing some data sharing through web services, or there are some workflows which you need to interact with a lot of information that they need to process. You can very well use PubSub, and these are some of the benefits that you would get in return, and you'll be in a better position to have your communication in place. Next, we'll talk about what is continuous query. It's CQ is a lot similar to PubSub. This is the PubSub architecture, and CQ is almost like this. But the only difference is that CQ is based on the data set, right? So you get subscribers who actually register a SQL query or a link query. It's entirely up to you what your platform is supporting. I'll give you an example of NCache. This supports SQL-like query, and it allows you to map a data set in the distributed cache. It could be a database as well, and then any changes in that data set would trigger event notification. So you would get notified about the events as soon as a new record joins the data set, or an existing record gets updated, or an existing record gets removed from the data set. So you might want to get notified, right? So again, there's a communication channel. The difference here is that communication channel also has some data in it, and then you map some records from that data using a SQL statement, using a criteria, and then based on that criteria, the subscribers get notified as soon as there is a change in that data set. So it's slightly different. There doesn't have to be a publisher who's actually sending a specific data. It could be a publisher, or it could be an application which is actually making changes to that data set. But it can work even without that. As soon as any application changes data in the source, it actually triggers a notification, and then subscribers get notified. Now, what are the common use cases of continuous query? We know that it's different, slightly different from PubSub, but it's a lot similar in many ways. You have a communication channel, you're dealing with subscribers get notified. Only difference is that there is no real publisher which is sending messages, but instead there's a criteria, and there are records and records of interest that you would like to get notified as soon as there's a change happening on those records. So you would like to use continuous query in scenarios where you're maintaining some data in memory or within the application scope, and accessing the database is expensive, or the sources are expensive. So in that case, you simply want to get up-to-date information by using the continuous query. So you register your interest, and based on that, you get notified for the up-to-date data set as soon as that data is made available. Then it's async decoupled communication, similar to PubSub. So if that's a requirement with the data, you can use continuous query. Again, it avoids your polling. It's a push against poll mechanism. You don't have to poll for new data set. It may not change for hours, right? So you don't need that data at all. But if it does change, you would get notified via push notification to the to the client end. And then most readily accessed queries can get instant updates. And for example, you have product catalogs, right? So those could change. Frequency of change may not be that great, but that's a query to the database or to your communication channel, which would be happening very frequently, right? So you need to publish your products onto a page very frequently for almost for every single request. So if you cache that, if you have that information, and you've already made that query, and then you have a continuous query running on the server end, you can get notified if a new product joins the product list, and then you can actually get the updated values, get the individual product which got updated, added, or removed, or you get to query again. It's entirely up to you how you design your application. So this is the diagram for continuous query. I've used NCache messaging, continuous query messaging diagram and platform as an example. So you register a continuous query. It could be a select product where product.price is less than $100, and then you could select orders of a certain where order.customer ID equals to something, or there are orders of certain customer that you are interested in. So, and then you have CQ subscribers. Any application changing data here, there could be a lot of data here, hundreds and thousands of records, but you may have mapped only 10 or 20 or hundreds of those. It's entirely up to you how you design it. So this is a concept of topics, but these topics are not just named topics. These are database or data-driven topics, and they're mapped with the help of a criteria, and that's what a continuous query, which is continuously running on the communication channel. And as soon as there is a change in the data set, a new product joins, a new record gets added, and matches the criteria, existing record gets updated or removed, you get notified via callbacks, and you actually get notified about the records which have joined the criteria, or which have been updated in the criteria, or which have been removed from the criteria. So it's very flexible in that case, and you can run as many continuous queries as you want. They would be running continuous queries, and as soon as there's a change, it would notify all the continuous query subscribers. Please let me know if there are any questions. We've built some basic details around PubSub and continuous query. We've also talked about some of the benefits of these features. In general, these are going to be serving as advanced messaging features for your server application, or even for serverless applications, as discussed earlier. Any questions so far? Next, I'll talk about some of the important use cases for PubSub and CQ. The most common use case, or the ones the one that we're seeing very frequently these days, is IoT devices, right? So you can have data control. You can have powerful way of internet connected devices to stream, receive, manage, and monitor data using the PubSub platform. So that's one of the use cases. It could be your workflows and workloads where you need to relay events, you need to perform some batching, some bulk processing, data sharing requirements, app coordination. So all sort of workflows and workloads can be managed with the help of PubSub and CQ. Chat, gaming industry. I've already given an example of SignalR. So chat is another example where you can utilize PubSub and CQ. Gaming industry can host your tournaments information, players information, and then it could actually publish a lot of information around those games or tournaments to all the users at once, and they can use PubSub for that. Finance, e-commerce, bookings, the list goes on. You can have orders, booking, processing, tracking, some backend, management. So this can also be done with the help of PubSub. And then it could be automation, manufacturing plants, anything which actually relates to sharing data, processing data, sharing information. So that can be a candidate for PubSub. And like I said, list goes on. All right, so now that we've built enough details around the basics of PubSub and its specifics, we'll next talk about what are the problems, what are the traditional messaging platforms, and what are their associated problems. First of all, I'll cover .NET use case first. Within .NET side, we don't have a lot of messaging platforms. We have some, but those are not elaborate, and the ones that we have, they are traditionally scalability bottlenecks. The problem with PubSub platform is that it needs to be very robust. It needs to be very elastic, very scalable, and high performant. And then in some cases, it needs to be highly available as well, because the PubSub mechanism drives through your communication channel, and that needs to be up and running, and that needs to deliver messages in a faster manner, in a more scalable manner, in a more reliable manner. So traditional messaging platforms such as MSMQ or RabbitMQ, or even if you're using your database as your messaging platform, this is going to be slow, and this is not very scalable in general. When your load increases, when you're dealing with lots and lots of messaging data under extreme processing, it can give you high latency issue. It can also give you throughput related issues. You may get low throughput, high latency when your load increases. And this is a diagram which illustrates this, where you have your publishers and subscribers connected to it. It's usually a single source. There's a limit where you can scale up, and you don't actually have ability to scale out. And for those scenarios where you have ability to scale out, those are not going to be very performant, and that too under peak load. So that's our traditional issue, a bottleneck with our traditional messaging platforms, where PubSub and CQ may not scale well. With CQ and PubSub, you could have a lot of topics, a lot of queries running, and if you don't have a lot of memory and computational power in combination to one another, if it's a single source, you can end up maxing out the resources on the source communication channel, and then you don't have ability to scale out. So that's our number one problem that we'll tackle in upcoming slides. Solution is very simple. You need a distributed caching store such as NCache, which is a .NET based distributed cache, which is super fast and it's linearly scalable. So first of all, it would allow you to store everything in memory. So all the processing of messages is in memory, so it's super fast, and then it's linearly scalable. You can add as many servers as you need to, and it would actually scale out without any issues. Here is NCache diagram in comparison. So notice there's only one source. With NCache, if you're running PubSub and CQ, your .NET applications connected to another set of .NET applications through PubSub platform, and you can have multiple servers. All Windows environments are supported 2008, 2012, 2016, and then you can create a cache cluster which can pool all the resources. So you have CPU, memory, and network interface card resources pooled together, and these are team of servers which are working in combination to one another and dealing with all your increased amount of messaging load, which can be ever increasing, and you don't have to worry about anything. You can simply add more servers to increase capacity. So that's in comparison. I have listed down some of the benefits of using NCache over other messaging platforms. So first of all, high latency. That's the number one issue that you would face as soon as you have message load growing. With NCache, it keeps everything in memory, and not just that, you have multiple servers which are working in combination to one another, distributing the messaging load among themselves, and they still have the same topic, same PubSub nature, but it's just that behind the scenes there are multiple servers which are taking care of the load. So you would get low latency for the message delivery, so improved response times for your message delivery. And for real-time applications, this could be your number one requirement, where it can impact your users if data is not delivered in a timely manner. Then we have linear scalability. You can scale out basically by adding more servers. So as your messaging load grows, you can simply add more servers to the caching tier, and then you can increase the capacity of how many requests, how many messaging load or messages per second you can handle. Then we have reliability with our application. So it's highly available. Any server which is part of the communication channel in the distributed cache goes down, you don't have to worry about it. The surviving nodes would take over. So this messaging platform would be up and running, and it would be highly available, and very reliably it would actually transfer data. So first of all, data needs to be transferred in a fast manner, in a scalable manner, and then it must be transferred even if there is a maintenance that you need to perform. If you need to bring down a few servers, or those servers go down from the communication channel. So communication channel is the backbone for PubSub, and that's where we're targeting that NCache is a better solution in comparison. Then there are some other features such as security. You can set up security and protection with the help of security and encryption features which come as part of NCache support. Without any code changes, you can compress the payload and decompress on the client end. Then you can also set up security features and encryption features so that you can encrypt data which is being transferred between subscribers and publishers. And then platform flexibility. NCache can be used with by .NET as well as by Java applications. So it could actually be utilized between .NET and .NET applications, between Java and Java applications, and also between .NET and Java applications as well. So you can share data between two different stacks as well, and it would work without any issues. So PubSub can be utilized between .NET and Java without any issues. So here are some of the benefits. There are many more. I'll cover some specifics of the implementation as well in next 20 minutes. But please let me know if there are any questions. If there are any questions around the architectural details, please let me know, and we'll take it from there. Nick, I can't hear you. I think there's some issue. I think I can.
Can you hear me now?
Yeah, I can. Finally, yeah.
Okay. I had to switch the mic. There's a question about is there a version of NCache for .NET Core?
Yes, absolutely. On the client end, we have .NET Core client available. So our current version, our 4.8, 4.9, even 4.6 SP3, those fully support .NET Core. You can have .NET Core 2.0 client libraries which come installed with NCache. There are NuGet packages as well, so those would fully work with NCache. As far as server portion is concerned, since .NET Core, you can also run server on the Windows as well as on the Linux environment. So that's something that you can also utilize with NCache. So we have full support for .NET Core, and these applications could be based on .NET Core as well. As a matter of fact, we've done a webinar just on .NET Core as well. You could find it under our webinar series. I hope that answers your question. Very
sure,
good.
Thanks.
Very good. All right, so let's talk about PubSub messaging with NCache, how we've implemented it, what are the main features, and we'll take care of some of the specifics of NCache PubSub messaging support. So first of all, NCache messaging is very similar. You have a distributed cache right here. That's the deployment diagram, and then this is the architecture breakdown. So we have topics similar to the initial diagram that I've shown you, publishers which send messages, and then these are relayed to the subscribers. And then we have a dedicated cache for this that you can create, and you can add as many servers as you need to. This is a quick overview of PubSub messaging, publishing. This could be your order payload. You connect to the cache by initializing it, create a topic or get connected to the topic, create a message, pass on the payload to it, and call publish method. That's how simple it is. And you just need to connect to the communication channel, which is a PubSub cache in this case. Then subscriber again needs to connect to the same communication channel, needs to connect to the certain topic, and then it creates a subscription for it, and then it actually gets a callback. Subscription also has a callback, and that method can be used to perform operations. These are the main components of PubSub interface within NCache. You have a topic, a channel for communication, contains list of subscribers as well. It relays your published messages to itself to the connected subscribers. Similarly, publishers are also connected to the topic, and then they send messages to the topic, and then topic is within the communication channel, which in turn sends it to the subscribers. Now we have messages. That's the object of interest for subscribers. Publishers are sending this to subscribers. It's a serializable payload. Then we have publisher, the main driving factor, which is actually publishing the messages to the communication channel. It can also have optional delivery failure or delivery success status notification as well. But this is against the typical PubSub implementation. This is why it's optional. And then we have subscriber, which registers itself for a specific topic to be, so that it can have all the messages relayed to itself. I'll show you these interfaces real quick, one by one, after the architectural breakdown. So publisher creates message, register events, publishes messages. These events are optional. Sends message to the topic. Topic stores those messages. It can have some expiration times as well. Stores list of subscribers, and then relays events to the subscribers. And then subscribers have subscription, and then they have message notification callback as well, and then it also sends the callback, and then the whole picture gets completed. So this is what I'll show you with the help of interfaces as well. So let's take you to our environment, and before I actually do that, let me just create a cache first. Let's create the communication channel. Since we've defined that there is the pub sub mechanism gets driven with the help of topic and messages and publisher and subscribers. So let's first of all create a communication channel. Let's have a topic and message discussed, and then we'll publish some messages, and then we'll have some subscribers receiving those messages. So I'll log on to our demo environment real quick, and I have already installed NCache. This webinar is not focused on NCache installation configuration or how you would go ahead and create the cache. It's more focused on PubSub, so I would assume that you already know, or you can actually review our other webinars to have specific details of how to set up NCache. So I'll just set up a quick cache for communication for PubSub. I'll have 2 servers to start off, and like I said, you can add as many servers as you need to, and I'll keep everything default, and I'll start this cache as well, and then I'll add my client node. Alright, so it's started. I'll add my client node as well, which is my machine right here. And that's it. This is ready to be used by my application right here, which comes installed. So this is a sample application that I'm using. I have created some of the methods here. Let's go to the start method, and you could see that this is connecting to the cache. This is the publisher code. It is getting a topic, and then let me show you what our topic interface looks like. That's an iTopic that we have, and you could see that there is a name of the topic, message count, expiration time is closed, delete callback that it triggers, and then failure notifications as well. And then there are iTopic subscription method. That's the main method where you can subscribe as a subscriber. Alright, so coming back to this, that's how simple it is. You initialize the cache, create a topic through cache.messaging service. Right, so this is iMessaging service. If I show you the iMessaging service as well, it allows you to create a topic, delete a topic, and then get topic. And since NCache is open source, so all of this is available as part of our open source offering as well. So you can actually see implementation of these methods as well. Alright, so next thing is to publish. There's another method that we've implemented for it. We have a message. We already have the communication channel up and running right here. I've shown you the topic interface. Publisher can actually publish message. This is an application which is going to act as a publisher. Next thing is the message. Message has its own properties. So this is the message class right here. We have message ID, some expirations, some payload, which is a serializable object, and creation time as well. So that completes the overall implementation as far as message is concerned. And then we have topic.publish message and delivery option to all. You could have delivery options to, for example, let's see what the options are, to any or to all, right? So that's very simple in terms of the all means that it would actually be published to all the subscribers. Any means any one subscriber gets it, it would be removed from the communication channel. So that completes our publisher side. These are the code, iMessaging service. You initialize, create topic, or get connected to it, and then you have the subscriber side of things as well. Let me show you that real quick. Alright, on the subscriber end, again, you have initialized the cache, you get a topic, assuming that it's already there, and if it's not, you create a topic, and then you create a subscription, and then you have a message received callback. This message received callback is actually passed on to this method, so I should be going back right here, the caller program. Let's actually open the, so this is the one which is actually calling the callback topic delete callback, and message receive callback, which are right here. So these are the callbacks which are going to be received on the subscriber end. So let's run this application. I'll run it from the publisher end without any subscriber, so that I show you the decoupling of this in nature, how it is decoupled. So assuming that I'll have a publisher up and running, and it would publish 10 messages right away without having to worry about any subscribers. It's building it, and it'll take some minutes, and then we'll take it from there. I can also show you step-by-step execution, but let's first run it, and then I'll debug it and run it for you. There you go. It has published about 10 messages. There's no subscriber. Let's have a subscriber running. For example, let's run this subscriber right here, and you would see that all the messages are going to be delivered. And as soon as it's running in debug, let me just hit play. There you go, 10 messages are received. Let me run another instance of the publisher so that I add some more messages, and this time you would receive some more messages right here. There you go. So as soon as it published, messages got received. Now let me just run this in a debug mode. I'll keep the subscriber running, or let's actually do this step by step. Alright, so I'll just hit the breakpoint at startup. Alright, so it's getting the cache name, topic name, and it's going into the publisher, right? It created a publisher, and then it went into the publisher.start method, initialize the cache, right? So it gets connected to the communication channel, and then it creates a topic, right, from the web, and then it is started. And now next thing is that it actually publishes it. It has a failure notification. That's an optional thing that you can do, and then it actually starts publishing the messages in a loop. For some reason it's not giving me the control back, but just to let you know, it's going to publish the messages with 5 minutes of time span. And the whole point of this, actually I'm running in debug, so the whole point of this publish is to actually publish these. Actually, I'm in the publisher. Actually, it's a actual NCache method, publisher.publish payload, which is actually publishing messages one by one in a loop, so that we actually have the publisher sending messages to communication channel. And similarly, I'll show you the subscriber side of the code as well, running it real quick, and then I'll run the subscriber side. Again, it has published 10 messages, and then I'll show you the subscriber in a debug. There you go. So we have again topic that we need. I'll go inside this subscription method. For some reason it's restricting me to debug into it, but just to let you know, if I run it, it's going to have those messages relayed to it. And let me just show you the code step by step. So we have subscriber.subscribe method. That's our own method within this sample, and then in this we are actually getting connected to the topic, creating a subscription, and the message received callback. And the method, the value that you're receiving is message received is part of the callback method that we've implemented in this. So if I show you the callback, message not delivered reason, and similarly if I show you the received callback, it has the message received, text. So that's how simple it is. We have a pretty detailed help document available around PubSub. Step-by-step guide covers creating a message, creating a topic, or getting connected to the topic, and then publishing the messages. And on the subscriber side, set up a callback and then get the subscription done by connecting to the topic again. So this, step-by-step publishing and then this is a step-by-step, subscribing and receiving messages. Some features on the PubSub, and then we'll move on to our continuous query feature. You can have message invalidation. You can have message level expiration attached to the items. It could be topic level expiration as well. So messages can have their own expiry, and then topics could have expiry on their messages as well. Then message receive notification. You can subscribe and register for callbacks. Async delivery of messages is something that is going to happen. Delivery failure notification is another optional feature that you can use, and on top of it you can set up encryption and compression, and it's something that you can fully monitor. You could actually log on to these servers, and whatever is happening, for example in the monitoring clustering tool, NCache monitor tool, it's simply going to allow you to monitor everything with the help of dashboards, and then you can have your own topic statistics as well. For example, if I drag and drop here, so we have topic statistics here as well. So if I run this application again, it would actually have some statistics around topics, how many messages, how many operations or capacity this is exhibiting. I hope this helps. Please let me know if there are any questions around PubSub mechanism within NCache. I'll spend some time on continuous query, and then we'll move on and conclude this presentation. Next segment is around continuous query. So I'm assuming there are no questions. I think Nick just confirmed it.
Yeah, no questions, Rob.
Very good. Okay, so next I'll actually get started with continuous query. Again, this diagram. So in this, we'll set up a continuous query, and then we'll get notified about the updates to this continuous query with the help of callbacks. So that's the idea. This is our continuous query class. Steps are very simple. You initialize the continuous query cache, which we've already done as part of our PubSub. Create a continuous query for monitoring purposes, then register for cache events for that continuous query, and then register it on the cache first, and then subscribe to those events for continuous query, and then you can unsubscribe if needed towards the end of your application. So I have a sample application. Again, it is initializing the cache, creating a customer, add object to the cache. Let's actually go inside this method. So it's adding an object in the cache. You can have multiple items, and then it's creating a continuous query. And let me show you the continuous query class first. So that's the main class. We have a query, values, the operators, the parameters of this query, and then register add notification, clear notification. Then you have remove notification, update notification, and then you can unregister these notifications as well. Right, so I think this method right here is deprecated, but other than that, all are still intact. I'm not too sure on the deprecated part. Alright, so the way it works is that you have some items in the cache, and you select a data set from those items in NCache. You have a customer object where this.country. You need to index those objects with NCache. I'm using this cache right here, and I've indexed those objects. And next thing is that you actually set up this continuous query by passing on this statement and create a continuous query object. And then you can, and by the way, this method right here is registering the continuous query. If I bring it right here, this sets up my continuous query. This code right here sets up my continuous query to be set up on the cache for monitoring purpose. NCache will start monitoring, will register this continuous query, and will now wait for subscribers to get registered to it. Next thing is, on the subscriber side of the application, you actually subscribe for query data modified, query data notification callback, and you can even specify that you're interested for items added to it, items updated to it, items removed to it. One thing could be that as soon as you get notified about these callbacks, let me actually take you to these callbacks. You can run this continuous query again, or you can do some own custom logic. It passes on the object that got added or updated or removed. Or it could be very easy to actually run the continuous query yourself. Let me just take you to query data in the cache. So you can run this continuous query directly as well. You can have continuous query passed onto it, and then you can run execute reader, and as soon as there is an update, although we pass on the individual objects which get updated, added, or removed, but just to be on the safe side, you can run the complete query again. This could be expensive, but this gets the job done. Other alternative would be that you have the callback method that you've set up. You update your data set by using the object which was made part of that callback, right? So the callback arguments have the object added to it. So this CQ event arguments, I think we're using these somewhere. For example, let me just show you. It has old item, it has item, it has the query and the cache name as well. So this gives you all the information that you need around the data set and what exactly got modified within that data set. And then you can make changes, make amends to your data set as needed. Again, I would give you an example of e-commerce application, product catalog. You had 100 products that you loaded on a page. One option is that you poll for those 100 products again and again and again. And that would be expensive trips to the data sources such as NCache or database. Although NCache is fast, but still there's a hop involved. How about NCache registers that data set with itself and then sends you a notification that a new product has joined. So one option is that you query again, which could again be expensive. Other option is that the updated product that we passed on to you, you can simply add it to your products catalog, and that would actually complete the execution. I'll run this sample application real quick and show you this in a step-by-step mode. And please let me know if there are any questions. We're almost towards the end of this section here. I'll complete this, show you some of the clustering capabilities that you have as part of NCache messaging platform, and then we'll conclude it. Alright, so this method right here, I'm going to go inside it. Initialization is straightforward. Let me just show you how that gets done. I'm initializing the cache, so that happens. It's a one-time operation. It will take some time, but it gets the job done. And then I'm adding an object to the cache, and then I'm registering the continuous query here. I've created the query, this item based on the criteria of the item, and then I have created the continuous query and I've registered my CQ right here as well. Its exception, there's no event registered because I actually moved this piece of code right here. Let me just make that amendment real quick. Alright, so it actually requires you to register some events first, and then it allows you to register. So I'm going to bring it right here and then run it one more time. I'm having a hard time today in getting this to debug, but I'm pretty sure I'll be able to do this time. So let's see how it goes. Although it shows ready, but it's not giving me, let me just run it right away. The way it would run is it would actually add an item to the cache, register the continuous query, and then let me see if that's the problem. Maybe it's coming here, but not. Alright, got it. Alright, so I think I already added the items, so let's do this and then show you the continuous query sample application one more time. I hope to run this time. It's running fine now. Initialized it, and hope to get the control back, and then I'll register the continuous query. It's obviously taking a lot of time, so let me run it one more time, otherwise I'll just show you the code and then we'll conclude it. I was able to run it without any issues. Hopefully this time it runs, because I've not put a debug point up till this point. There you go. Okay, so at this point we have an item added to the cache, continuous query is registered. We fetch that item, and then we expect events to be called. I'll just update this. I'll just hit the next key so that it updates it, but I'll show you that there is a continuous query data modification event received. John Matthews updated now. Similarly, I'll just delete it. Sorry, I'm getting all sort of issues here. I think this will be one last try. Alright, so updating the customer should trigger a callback right here, and then I've deleted the customer, and again it has a continuous query data modification event received from, and it is a removed event. Let me just add it back, and this time it's an update call, but still it's add to the cache, so it's a data modification event with data added. I'll just remove it one more time so that you see the delete, and then I'll add it one last time so that you see the update as an add, right? And if I do an update one more time, it would this time be the update callback, right? There you go. Now you have updated in the cache. So that completes our continuous query execution. I'll show you the code real quick, and after that I think we should conclude this. Alright, so we're inserting it, and that's what this code is doing, and then we're deleting it, and towards the end we're unregistering it. So this is the main code that you need to take into account. You need to set up a continuous query, set up some callbacks, and then register it with NCache, and that's pretty much it. I apologize for the inconvenience towards the end where I was not able to debug it effectively, but towards the end I think that's what was needed, so it was done. There are some features within NCache which are very important. It's linearly scalable, it's highly available, replication and reliability is built into it, and alongside that we have security and encryption features as well. It's 100% peer-to-peer architectured, no single point of failure. Connection failover support is built into it. Any server can be added or removed on the fly without stopping the cache or any of the clients which are connected to it. So dynamically you can make changes to your running cache, and it will be 100% uptime, a highly available cache scenario. For PubSub and CQ platform, you can add or remove server, and your publisher and subscribers can continue working as long as there's one survivor node up and running. They're already decoupled in terms of publisher and subscriber. They're loosely coupled with communication channel, but with having redundancy within the communication channel, which is already very fast, very scalable, you actually take away all the issues that you can face for your applications, where you can add remove servers at runtime. And then there are a lot of topologies: partition replica. These are most common ones. Do you partition data, and then each partition has a backup on another server, so data is also made available. Your messaging load would be transmitted, distributed on all the servers, and will be transmitted by all the servers in combination to one another, and any server going down would not have any impact on the communication channel at all. So this completes our presentation. We discussed in great detail what PubSub is, what are the common use cases, shown you some hands-on examples of PubSub and CQ, and towards the end we also discussed some of the clustering capabilities within NCache. I hope you liked it. I'll hand it over to Nick, and we can take it from there.
Thank you very much, Ron. Guys, if there are any questions, kindly type them in now. we're at the end of the hour. Perfect timing, Ron. Thank you very much. If there are any questions even afterwards, you can send us an email at support@alachisoft.com, and our tech team will be more than happy to work with you and help you answer those questions. For any sales-related questions, you can reach us at sales@alachisoft.com. Again, I don't see any questions, Ron, so I think let's conclude this. Thank you very much, everybody, for joining us today. Really appreciate it, and we hope to see you again in the next webinar. Thanks, Ron.
Thank you, Nick. Thank you, everybody. Thanks, guys.